computer. Okay. All right. So we're going to be looking at indefinite integrals that have trig functions in them. Then we're also going to be looking at a definite integral. Okay. So you've got a little bit of basis coming into this since this is day 2. All right. And hopefully all of the trig integrals that you have memorized at this point. Okay. If not, I would work on memorizing them. So let's say we're going to integrate 4x to the third sine x to the fourth dx. Okay. All right. Now I'm going to, for today, I think I'm going to do this in a separate color. You don't have to do it in a separate color, but I do want the work set up in this way. All right. Obviously, this is going to be a u-substitution. We're into this u-substitution. You've already done an assignment on that. You've got to find what you're going to let your u be. Okay. Can anybody pick what u is going to be on this one? Like if you had to pick something, what would you pick? I have silence.
The x to the fourth inside of the sine function.
The x to the fourth on the inside of the sine function. Very good, Josiah. Okay, now, can you tell me why you chose that?
Because if you had to take the derivative of sine x to the fourth, that's not going to be very pretty.
Okay, yeah, well, that's true. It's going to be in chain rule. All right, this is the inside most part of that sine function, right? If you can think in your head a little bit ahead, all right, what do? We let u equal something, and then we take the derivative of it. All right, well, if I'm looking at that x to the fourth, and I take the derivative of that, what am I going to have? I'm going to have a 4x to the third, all right, which I have right there, which is going to cross out. The whole point of this is I want to get all my x's crossed out so that I have this in terms of u. All right, so I'm going to, all right, and I'm going to be very picky. If you do this on a written test for me, you must have the word let. I will not let you skip that. That has to be there. All right, we're going to let u equal x to the fourth. Okay, then you're going to take the derivative of both sides. So when I take the derivative over here, I'll have a du. When I take the derivative over here, I have a 4x to the third dx. All right, now, different people do it different ways. If you watch other videos on YouTube, they're going to not necessarily go all the way down and solve for dx, because sometimes they do here's this, and I can circle this, and they do a circle thing, and I just don't like that. All right, so I solve all the way down for dx. So in other words, I divide both sides by 4x to the third. So I have a du over a 4x to the third, and that equals dx. All right, I want that part right here, all right, underneath, so that we can come up here then and keep going across, and then we can come down with our problem. All right, so now I still have the integral right here. I still have this 4x to the third. It stays there. I have a sine, okay, but when I get to the x to the fourth, I want to put in my u, all right, because that's what I let u be, all right, and then I'm replacing dx with what it equals, so a du over a 4x to the third. Okay, and then that lets me cross out the 4x to the third and the 4x to the third. So my x's are all gone. At this point, I know I'm doing my u substitution correctly because all my x's went away, and now I have an integral in terms of u. Okay, from here, I can integrate this, right? Integrate sine is what? Negative cosine. All right, this is where you have to have this stuff memorized. All right, so negative cosine u plus c. All right, it's in terms of u here. It has to be in terms of u here. Now, this is not my final answer because my original problem was in terms of x. This is in terms of u, so I need to come back and replace. So I've got a negative cosine x to the fourth plus c. Okay, so you did u-substitution in your first assignment, and it just, I don't think that first assignment had any trig functions in it at all. All right, and so we're going to take a look at some of these trig functions. All right, so for the most part, that one is pretty straightforward. All right, when you've got your trig function and you've got, like, this is a composite trig function, right? It's got an inside, it's got an outside. That inside there is a really good possibility, good choice for that u-substitution, because it's probably going to help something cross out. All right, now let's go ahead and do another one, a pretty straightforward, simple one. Okay, and then we'll go to a little bit more challenging one. Let's suppose we had something like, let's just do the integral of cosine of 6x dx. All right, again, this is going to be a pretty straightforward one. All right, composite function. My outside function is cosine. My inside function is 6x. I don't have to worry about anything crossing out, all right, but I'm going to look at the fact that that 6 is on the inside of that composite function, all right? So I'm going to let, I'm going to switch to red because I didn't like the pink on the other one. Let u equal that 6x, all right? Take a derivative of both sides. So I'm going to have a du, and then I'm going to have a 6 dx. Okay, divide both sides by 6. Du over 6 is equal to dx. All right, I cannot emphasize enough how important this is. This is a composite function. All right, I have people that look at this and they just go, oh, well, derivative of, or sorry, integral of cosine is sine. So then they just tell me sine of 6x, and that's all they write down. Then they do the plus c. All right, if you don't do the u substitution, you miss the part that gets pulled out. All right, so when we come back up here, I write the integral, I keep cosine, all right, but I replace the 6x with my u. I replace dx with du over 6, all right, and here is the 1/6 that gets pulled out. That's the part you miss if you don't do a u substitution. Right here is 1/6. It has to get pulled out in front of that integral. Okay, so then I have a 1/6 integral cosine u du. All right, now I can integrate. I have just a plain u here, so that allows me to do a 1/6. Let's see, we said integral of cosine is sine. So sine u, add the plus c at this point because you have integrated. All right, last step, replace u with what it is. So 1/6 sine 6x plus 6. Okay, and like I said, people will miss this because they won't do the u substitution. They're going to look at this and they come up with sine 6x plus c. They miss the part that gets pulled out. Okay, so again, straightforward on that. Okay, you might have to rewrite trig-wise to see what the inside function is. All right, I'm not going to do this entire integral, but let's just set it up to begin with. Let's suppose you had the integral of a sine x over, what if they wrote it like cosine 3x dx? Okay, like I said, we won't do this whole entire one, or maybe I should. Should I do this? Maybe this is nasty enough. I should do the whole thing. All right, if I'm going to do the whole thing, I'm going to rewrite it. And I got to looking at that, and that's harder than I thought it was going to be. Okay, so let's go integral. Well, what did I write down? I wrote down sine x. I wrote down cosine to the third x dx. Okay, so what I might do, all right, we've done this before. We've switched this. All right, yes, this is a composite function, right? We've got an outside and an inside. All right, I might rewrite first. So let's do it like this so you know that all I'm doing is rewriting. Okay, let's leave the sine x on top. Let's write that as a cosine x to the third power. If I do that, all right, then hopefully you can see that really my outside function is something being raised to the third power. The inside function is that cosine x. All right, that's the whole point of why we might want to rewrite, because now that's going to help you find what you're going to let u be. All right, the inside portion here is cosine, and stop and think about that. If I take the derivative of cosine, I get negative sine, all right? And I have a sign sitting up here that's going to be nice. That means it's going to cross out. Okay, so I'm going to let u equal this inside portion, so cosine x. Okay, I'm going to take the derivative of both sides. Du, derivative of cosine, negative sine x. Don't forget the dx. All right, divide both sides by negative sine x because we want to solve for dx. So du over negative sine x is equal to dx. Okay, I always do this just kind of separate it out. All right, I'm going to come back up here. Now I'm going to start replacing everything that I can here. All right, my sine x on top is going to stay. This is what I let u to be, so I'm going to replace that with a u, so that'll be a u to the third. My dx, I'm going to replace with what I let it equal to, so a du over a negative sine x. Okay, our goal here is to get rid of all the x's. It's going to happen. Sine x crosses out with sine x. All right, now don't forget the negative right there. That negative is going to get pulled out in front. Okay, so now I'm going to have a negative out in front integral of 1 over u to the third du. Okay, and then this one takes a little bit more effort here. I can't integrate that, right? Because we don't know how to integrate that. So we're going to do our laws of exponent. We're going to move it up and make it negative. Okay, so I'll have a negative integral u to the negative third du. Okay, and I haven't integrated from here to here. All that is an algebra step, so I haven't done the integration yet. All right, now this is a little -1 that's sitting out in front of that integral, right? So keep it there. I'm going to actually put it there so that we see it, it stands out. All right, I'm going to put a square bracket because now whatever I integrate is going to go inside here. Let's see, add 1, so that'd be a u to the -2. All right, and then put it 1 over that, so a -1/2 there in front. Okay, close those brackets. All right, plus c. Okay, now negative times negative is a positive, so I'm going to have a positive u to the -2 plus c. All right, probably you can do this at any point in time. I can get rid of that, put it down the bottom before. All right, if I want to put it down the bottom and make it positive, let's do that first before I put it back in. So 1 over 2u squared plus c. All right, what am I putting u back in is, cosine. I'm glad I did do this because watch what's going to happen. Cosine squared x plus c. Okay, now, are we right? Have I made a mistake yet? Anybody see a mistake? Are we all good? Someone verify you're all still awake for me?
We're good.
Thanks, Dane. Someone's got to entertain me. Otherwise, I feel like I'm just talking to myself. All right, now, because last spring we didn't go through tons of trig, all right, what I see something here. I don't know if you guys see something. What if I wrote that as a 1/2 times a 1 over cosine squared x plus c? All right, what if I just separated this so you see it a little bit better? All right, I know it was virtual learning last spring when we went through trig. All right, but that right there, 1 over, remember those reciprocal identities that we did? 1 over cosine is equivalent to secant. All right, these are squared, so that's okay. 1 over cosine squared is secant squared. They're reciprocal identities. Okay, so if you were sitting in a calculus class on a university setting, they would expect you to be able to simplify this. Not that there's anything wrong with this answer, all right, but to clean it up, make it look a little bit nicer. They're going to want to see a 1/2 secant squared x plus c, would be my guess. Okay. And this is where, like, you guys are like, those trig identities are so important. The Pythagorean Pythagorean identities, like sine squared plus cosine squared equals 1. All right, there's 3 of those that you need to memorize. I would say the next most important ones are those reciprocal identities. All right, 1 over cosine, 1 over sine, 1 over, okay. And then all of those reciprocal identities work when squared as well. You just keep that squared part. Okay, so I'm kind of glad we did that question and I didn't skip it because that's kind of important. Okay. All right. So questions. Are we good? Going forward. Don't hear anybody screaming at me yet, so we're kind of good. All right. Now, let's go take a look at some definite integrals. I want to make sure that the emphasis of the work is correct. All right. The way you place, where you place things and how you do it is extremely important. Okay. And the first time you did this, I believe you did it via video because it was a virtual day. I was not at school, something along those lines. So you had to do it via videos. So let's do this in person here now. All right, let's suppose that we are doing the integral from 0 to 1 of x times x squared plus 1 to the third power and then dx. Okay, now the way we're going to do this, all right, we're going to keep the same limits of integration. All right, we're not going to change our limits of integration until like after Christmas sometime. So we're going to work all of our problems out with limits of integration in terms of x. Okay. So how can we mark this? Let's do it this way. I don't want to mark the problem up too awful much. Limits of integration for x. Okay, I want to make a big deal about this. All right, this 0 and this 1 is only 0 and 1 on this integral in terms of x. All right, I've got a dx right here. This function is in terms of x. This is, I see all x's here. All right, dx. Okay, these are limits of integration for x. And right now, we're not going to change them. All right, sometime later after Christmas, when we come back, we will learn how to change these limits of integration for x to limits of integration for u. All right, but right now, we're not going to. So what that means is, excuse me, when we do our u substitution, and then we come up here and we rewrite our integral in terms of u, I cannot have the 0 and 1 in the problem at that point in time, because my problem will be in terms of u, but these are in terms of x. All right, and college professors really get annoyed at you when you mix them up, okay, because there is a big deal between this. Okay, now, so let's go ahead and work this out and I'll show you what I'm meaning. All right, so let's figure out what we're going to let u be. All right, stop and think about this. All right, do I have an inside function? I definitely have an inside function here, because my outside function would be something raised to the third. All right, if I do this inside part, if I take the derivative of x squared, don't I get an x? Okay, so that's going to help that x cross out right there. Okay, so I'm going to let my u be x squared plus 1, that whole inside part. All right, when I take the derivative of both sides, I'm going to get a 2x dx. Don't forget the dx. All right, I want to solve all the way down for dx, so I'm going to go du over 2x is equal to dx. Okay, now I'm going to come back up here to my original problem. All right, now at this point, this line is a little tacky. I don't know how mathematically correct it is, but when I first start with this, I'm going to have a bunch of x's and u's all mixed up, which is really bad. I do not want 0 and 1 right here. Okay, I'm going to keep that x, I'm going to replace this with u, so u to the third. All right, I'm going to replace that dx with what it equals, so du over 2x. All right, this is horrible. It's got u's and x's and everything else in there. So I definitely don't want to have limits of integration for x at that point, because this is all mixed up. Okay, I can cross those x's out. Okay, now I've got the what? I've got the 1/2 here that needs to be pulled out in front of my integral. All right, so on my next step, I'm going to have that 1/2 out. Integral of u to the third du. All right, but notice right here, I do not have a 0 and a 1 because I can't. 0 and 1 are limits of integration for x. I now have an integration problem in terms of u. Okay, so we do not want to put anything right there. Okay, now let's go ahead and integrate this. I can just keep going down. All right, I've got that 1/2, right? So it's going to stay out there. All right, integrate here, add 1 to that u, so I'll have a u to the fourth, and then put it over the 1 in front, so I'll have a 1/4. All right, we're pretty good there. Okay, plus c. Sometimes I put the bracket here, sometimes I put it there. All right, let's go ahead and simplify this. Okay, so this would be a 1/8 u to the fourth plus c. Okay, I still am in terms of u. All right, now let's put in our u to put it back in terms of x. So I've got a 1/8 and then an x squared plus 1 to the fourth. All right, now am I back in terms of x? Yes, I have an answer that I am completely back in terms of x. So now I can add the 0 and 1 back in because I'm now in terms of x. Okay, I am now in terms of x. I'm now back in terms of x. So those limits of integration for x I can add back into the problem. All right, so obviously you're not going to have to deal with this. Yeah. So I'm not going to have to, that was a superintendent wanting to talk to me. He'll be back. I'm not going to, you're not going to do this on the final exam, okay, because it's not going to be written. When we come back from Christmas, we'll have to go back over this stuff, and I will really make a big deal about this. I will make a super big deal about this. All right, so everything in here Everything inside there is in terms of u, and I do not have a 1 or a 0 in there at all. I do not have a 1 and a 0 in there at all. Okay. I know you may think, oh my God, you're going over and over and over and over this. Yes, I am. This is overkill. All right. And yes, right now doing it this way, it's going to make the problem a little bit more challenging as far as the arithmetic goes down here. All right. But there is a method to my madness. All right. We will learn how to change these numbers after Christmas. Okay. All right. So moving forward, all we got to do is now plug 1 in, plug 0 in. Okay. So the math's going to not be too awful bad here. All right. So I'm going to go ahead and put this all over 8. So when I plug in 1, how much of this can we do in our head? Probably not a whole lot. 1 squared plus 1 is going to give me a 2. 2 to the 4th is going to give me a 16 over 8. All right. Minus, if I plug 0 in, we got to be careful. Plug 0 in here, I'll have 1 to the 4th over 8. So just a 1/8. All right. Don't let me screw up here because this is not good. 15 over 8. All right. As long as I didn't screw up any math there. Okay. So 15 over 8. I know. Big long exclamation there. Okay. Did everybody follow things I was saying? Okay. How am I doing on time? It's 1:07. All right. So we should be good. All right. So I have tons of examples like this. Okay. Tons of examples like this. All right. Same old stuff, same old stuff, same old stuff. Okay. Now, sometimes though, this is going to create a problem. Okay. Sometimes whatever you pick for you is going to create a problem. So now I want to do a problem that's going to throw you for a loop. Okay. Got to decide which one I want. That one's kind of nasty. Let's do this one. This isn't too bad. Okay. Let's suppose we're integrating from 1 to 5. And I've got x over the square root of a 2x minus 1 dx. Okay. All right. Now, we got to decide something for you. All right. We have a composite function down here on the bottom. I've got an inside part. That's what we've been doing all along. We've been putting stuff in, the inside part of that composite function is what we've been letting our u be. So let's just try it because that's what you're going to do. All right, you're going to try this and then I want you to see what happens. We're going to let u equal that 2x minus 1. Okay, now let's go ahead and take the derivative here. So du is equal to, that's just going to be a 2 dx. All right, hopefully now at this point, some of you are already going, oh crap, this isn't going to work. All right, divide both sides by 2, and I get a dx. All right, let's go ahead and show how it's not going to work. Okay, I'm going to get rid of the limits of integration for x. Don't want them there. So plain integral. All right, that x has to stay on top. All right, this will be the square root of a u. All right, replace dx with what it equals, du over 2. Do we see the problem? What's my problem? Just so I know that you guys are awake.
X's won't cancel out.
Yeah, the x's are not, that x, I got an x left over. All right, x is not going to cross out. Okay, in which case, you got to figure out something to get rid of x. All right, so this is like a cool little trick. All right, let's see if I can come up with another color that's going to be different. All right, take a look at what you did right here. I've already said u equals 2x minus 1. All right, can I not take this and solve for x, so then I've got something for a u? All right, can't I take this u equals 2x minus 1 and then solve for x? So add 1 to both sides. So u plus 1 equals 2x. All right, and then divide both sides by 2. Didn't need to really do that. So u plus 1 over 2 equals x. And I've already used this once, so this is good. Like, this connects to this, so I am good. So now I've got an x left over. Now can I replace the x with this? And I'll have everything in terms of u. Okay, so let's do that on our next step here. I'm going to go ahead and go over. I'm going to replace that numerator with a u plus 1 over 2 all over. Can I probably at this point go u to the 1/2, because I think I'm going to have laws of exponents here, times the du over 2. All right, because that's just going to be a nasty little thing here we need to try to simplify. Okay, so can I pull out a 1/2? All right, so let's pull out the 1/2. Okay, now let's do, what kind of fraction I have here? Got a complex fraction? Can I multiply through by 2 and simplify it a little bit? So multiply by 2, multiply by 2. Those 2's will cross out. So then I can have a u plus 1 all over a 2u to the 1/2. Can I do that? Okay. Can I pull out a 1/2 here? Better put that u on there. Let's pull out a 1/2. All right. So that put a 1/4 out here. Stay awake on this, guys, because I am just doing the algebra like crazy here. I'm not following what's in my notes, so don't let me make a mistake here. U plus 1 over a u raised to the 1/2 du. All right, now I would venture to say lots of different ways to do this, but could I break it up into two fractions separately? I got a new numerator that's being added, so I could go u over a u to the 1/2. I could do 1 over u to the 1/2. Okay, because I don't think I want to move that up and make it negative. I think that would be a mess. All right, so I'm going to go sideways just because I'm running out of room here. Okay, so let's do a 1/4 here. Let's make this a u over a u to the 1/2 du plus the integral of a 1 over a u to the 1/2 du. Notice how I wrote all that. Okay, let's get this over a little bit. Okay, I made sure I put a du on this integral. I just separated this. I made this into 2 separate integrals. All right, I'm going to take a look at this, and I'm going to try to simplify those using laws of exponents. Okay, so coming down here, I'm still going to have a 1/4 out in front. All right, I'm going to have an integral. Let's see, subtracting that give me a 1/2, so I'll have a u to the 1/2 du. All right, a u to the 1/2 du. Don't let me screw this up. All right, moving this up, let's move that up, and then I'll have the integral of a u to the negative 1/2 du. Okay, all right, now we're ready to integrate, so I'm going to add 1 here. So I'm going to add 2 over 2, so I'll have 2, God, I can't add today. 2 over 2, 3 halves, so 2/3. Did I do that right, guys? Help me out. This will be, God, I am having a day. 2/3 u to the 3 halves. Y'all with me? Or are you asleep? Are you just letting me struggle? You're all letting me struggle. You're not helping me here. All right, so.
I'm like barely.
You're barely awake? Yeah. All right, so that's
I'm 50-50 on whether I'm awake or not.
okay. I'm over here having math and doing math and having fun. That should be like a 1/2. So this is going to be a 2u to the 1/2. If I screw this integration up, the problem's not going to work. We'll know when we get down at the end. Okay, so add 1, 1/2, flip it around 2. I should be good. 1/2, add 1, makes it 3 halves, flip it around 2/3. I think my integration is correct at this point. Okay, so now I'm still in terms of u, so I can't put the 1 and 5 back in yet. I am still going to run out of paper, even though I tried so much to not run out of paper. I'm still going to do that. All right, let's come all the way up to here. Oh, how can I put that? All right, so I think at this point, what do I want to do? Man, the math's going to be horrible. Okay, I'm going to distribute. No, maybe I don't. I don't think I'm going to distribute the. Got to decide if I want to distribute that 1/4 in now or later. Let's go ahead and do it now. Let's go 2/12. Let's make this the square root of u to the 3rd. Let's distribute again. That's going to be a 1/2 square root of u plus c. Okay, I'm still in terms of u. Let's plug my u back in. So I'm going to have a 2/12. Let's make that a 1/6. There's no reason why I need to keep that as 2/12. Let's reduce that to a 1/6. The square root of my u is a 2x minus 1 to the 3rd power plus a 1/2 square root of a 2x minus 1. All right, and now I can put the 1 and 5 back in. And then at this point, we are going to grab a freaking calculator, I think. All right, 1/6. All right, so plugging 5 back in, I'll have 10. 10 minus 1 is going to be 9. 9 raised to the 3rd power is going to be a 729. Again, don't let me screw this up. Plugging in 5 is going to be 10. Square root of 9 is going to be 3. So this will be a 3/2. Let's do that again. 10 minus 1 is 9. Square root of 9 is 3. Okay, so there's that. Minus, plug in a 1. 1/6. All right, so if I plug in a 1 there, it's going to be 2 minus 1 is 1. 1 to the third is just a 1, so it's just going to be 1/6. That's nice. Plug in a 1 here. All right, 2 minus 1 is going to be 1. Square root of 1 is 1. Okay, that should be good. Now, let's hope that the square root of 729 turns out to be a nice number. It does, 27. All right, so this is 27 over 6 plus 3/2 minus a 1/6 plus a 1/2. All right, total calculator at this point. I am curious to see if we have not screwed this up or if I have not screwed this up because you guys are not really helping me very much at all. Parentheses minus, you guys can probably plug it in faster than I can. Here again, I could be the only one plugging it in. You guys are just sitting at home chilling, waiting for me to get an answer. And I get, oh, yes, 16/3. That's the answers in my notes. We did this right. Okay, now, besides the fact that that was just absolutely positively horrible, I realize, definite integrals, all right, are horrible. Okay, so it just takes a lot of arithmetic. There are so many places that you can make a mistake. I mean, just unbelievable amount of mistakes. All right, so you just got to really be careful. All right, so this kind of stuff, I mean, you saw, like they don't work out fast. I would highly suggest you not try to do it fast. Let's pull this down to back to the beginning of this. The whole point of doing this problem, why did I do all this horrible thing? The whole point was right here. I wanted you to see that sometimes you're going to pick the right thing for you. All right. And then you're going to come over here and all your x's aren't going to cross out. So you don't freak out or anything. Take whatever you let u equal to, solve for x, and then you've got something else you can place it back in and get it in terms of u. All right. That sounds like somebody turned their mic off. Do we have questions?
Yeah, I was wondering, when we do this on a test, what lines are you going to, like, I know you said the let, but
Oh, yeah.
I know you grade like a specific line each time. Which line are you going to grade on this type of problem?
Well, definitely all of this part right here where we've done the u and the 2 different substitutions. All right. Usually then I get down to some form of one of these in a simplified form. All right. So probably I would look for this one right here because that's the initial plug it in, simplify. And then what you do from here to here to here is going to be, all of you will take a different approach on the algebra that you simplify. All right. Then when you go from the integral to the integration line, all right. So 1 for, do you have it all in terms of u correctly? 1, did you integrate correctly? Okay. And then 1 point for just random work for all this wonderful stuff down here, and then 1 down here for the final answer. So pretty much the same as all the others. Okay. So like, let me do this not on this because I got to keep shuffling this paper back and forth. So big. Let's do the exact same thing on a smaller problem. Okay. So this problem is much smaller. Okay. So I give you 1 point for the u. All right, I give you 1 point and I would take either one of those lines right there. But this means, this is tells me you have done your substitution right. You've got it in terms of u. All right, then I look for, did you integrate correctly? So then there's another point. So there's 1, there's 1, there's 1. I generally give you 1 for the work, in general, just a nice, give me point, and then 1 for the final answer. So this is cleaner to see all the points. Does that make sense?
Yeah, thank you.
All right, do we have any other questions? I think I'll go ahead and find my mouse and go ahead and zoom out so that I can see all your bright, shiny faces this morning. Oh, look, Dane's got a Santa hat.